Hello everyone. From this lecture onwards, you are going to start a new journey, and in this journey, you will understand a lot of things that will change your perspective towards your life. As the great physicist Richard Feynman has given one analogy, so let's discuss that and then we'll start the chapter 1 Introduction to Physics. So, suppose you want to play chess. Now, there are two scenarios. One scenario is that you understand the rules, and the second scenario is you don't understand the rules of chess. Now, one simple question: will you be able to enjoy chess if you do not understand the rules? I guess not. So, if you do not understand the rules of chess, you will not enjoy the game of chess. You will not be able to understand what is going on. You will think that the players are doing some random stuff and you will get bored after a certain amount of time. But if you understand the rules, you will see how intricate and how complex the game of chess can be, and how amazingly different players are trying to fool their opponent at the same time. So, if you understand the rules, you will start enjoying the game of chess. Similarly, if you want to enjoy and understand and love the nature around you, if you want to see how wonderful, colorful and diverse our nature is, you need to understand the rules or the laws on which this nature works. So, to understand the rules or to understand the laws of nature, we need to understand physics, or rather I can say physics is the study of nature. Physics is the study of the laws of nature. We try to understand the fundamental basic principles and rules on which the nature works, and that is called physics. If you look into the term physics, it comes from a term called physica, and the meaning of physica is natural things. So, physics literally means natural things, and we can say physics is the study of nature. The nature around us is very colorful, very diverse. There are so many variety of phenomena that is happening all around us every moment. The winds are blowing, the planets are moving around the sun, you can see the stars in the sky, you can see the rainbow, you can look at yourself. The intricacies of the human body is amazing. You can look into the machines all around you. In everything you will find there is physics some way or the other way. Physics is the most fundamental branch of science. It is the study of nature and its laws. The best thing about physics is it does not matter whether you are a big scientist or you are a big influential name or not. If your theory or if your ideas are backed by the experimental evidences, then you will be correct. And if your theory is not backed by the experimental data, then your theory will not be accepted. It does not matter whether you are the most influential person in the world. So there can be a new phenomena any day that can be discovered which does not go with the rules discovered by some great physicist or scientist, and it will not matter. The rules or the theories discovered by that scientist will not be accepted anymore. The name does not matter. Now you must have heard that physics and mathematics are interlinked with each other. You must have also heard that mathematics is the language of physics. So let's discuss a few points about that and then we'll move forward. So yeah, it is true that mathematics is one of the most important aspect of physics. If you want to understand anything and if you want to make a proper theory, then it is nowadays almost mandatory that you prove it mathematically also. The mathematical rigor helps us in formulating a theory even which is not experimentally yet proven. But one thing must be kept in mind, that mathematics is just a tool, it is not the entire physics. For example, alphabets and grammar and any language are just a tool to express any idea. It does not matter whether you express that idea in French, English, Spanish, Hindi or any other language. It's all about the idea. Similarly, mathematics is like a language and the idea is of the physics. So physics is the idea that we need to understand, and mathematics is the deluxe coach of a train that will help us in reaching that goal, in understanding the nature. Now let's discuss that what are physical quantities, what are the things that we can study in physics. So any quantity that is measurable is called a physical quantity. So what is a physical quantity? So any quantity that can be measured is called a physical quantity. So in physics we only talk about the quantities which we can measure some way or the other way. So let's discuss the definition of measurement. Measurement is the act of comparison. So measurement is the act of comparison of a physical quantity with a standard of the same physical quantity. What do I mean by this? For example, let's say we want to measure mass. So mass is a physical quantity because it can be measured. Now we have described a standard, that is kilogram. So 1 kilogram has been pre-decided that this amount of mass will be considered 1 kilogram. So when we have any other random mass, any object having random mass, and if we compare that mass with the standard, that is 1 kg, then we call that act as measurement. So let's say you get 3.5 kg. So this 3.5 is the numerical factor by which this object is heavier than the 1 kg block. So this is the times of standard unit, and this kg is the unit, it is the standard unit in which we measure the mass. So measurement is the act of comparison of a physical quantity with the standard of the same physical quantity. For example, in mass we consider kg to be the standard. So when we compare the mass of any object with 1 kg, then we call that process as measurement. Okay, so let's now discuss what is a unit. So unit is a definite value of a given physical quantity which we will treat as a standard for reference. So we can say that the reference standard for measurement of a given physical quantity is called the unit of that physical quantity. Let me write that. The physical quantities are generally of two types. One is the fundamental physical quantity and another one is the derived physical quantity. The fundamental quantities are the quantities which are completely independent of any other quantity, and the derived quantities are the quantities which can be obtained using the fundamental or the base quantities. For example, mass is considered to be a fundamental quantity because we treat mass as the base and we do not consider that mass is derived from any other physical quantity. And for example, velocity, it is considered as a derived quantity because we can find or get the velocity when we divide displacement with time. So fundamental quantities are completely independent and derived quantities are obtained from the fundamental quantities. Now before we proceed any further, who decides the unit? Who decides that mass will be calculated in kilogram, and what will be the definition of 1 kilogram? What will be the definition of 1 second? Who decides that? So there is a body called Conference General des Poids et Mesures. It is a French name. Its short form is CGPM, and it is also known as General Conference on Weights and Measures. So this institute decides the definitions of various different units. So now we will discuss about many different physical quantities. First we will start with the fundamental physical quantities. So there are 7 fundamental or base quantities. So first let's write the names of the fundamental quantities. They are length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. Now there are 7 fundamental quantities, and because of that we can say there are 7 fundamental units as well. So fundamental units are the units of the fundamental quantities. Now the units can be many different types. Like for example, for mass there can be kilogram, gram, tons, quintal. For example, for length there can be units such as kilometer, meter, centimeter, millimeter. So there are many different units. So we usually discuss about or usually use the SI units. So the abbreviation SI comes from French name Le Système International des Unités, or in simple English, International System of Units. So SI units are the units which are most commonly used, and scientifically these units are most common, and in general these units are also quite common. For example, for length the SI unit is called meter, for mass the SI unit is kilogram, for time the SI unit is seconds, for electric current the SI unit is ampere, for temperature the SI unit is Kelvin, for amount of substance the SI unit is mole, and for the luminous intensity the SI unit is candela. Hopefully you might have heard about most of the SI units or quantities, but for example amount of substance or luminous intensity, they might be new for you. Now the SI units have particular symbols. For example, for meter small m is used, for kilogram small k and g is used, for seconds small s is used, for ampere capital A, Kelvin capital K, mole is small m, o and l. Then for candela small c and d. Now each of these units are defined. For example, 1 meter is defined, 1 kilogram is defined to be a particular quantity. So let's quickly see what are the definitions of 1 meter, 1 kg, 1 second, etc. Just keep in mind that you do not need to remember everything. It's just for the sake of understanding that how the units are decided. Okay, otherwise you do not need to completely mug up all the definitions that we are going to discuss. So here we have got the units of different quantities. The first fundamental quantity is meter. Meter is defined as the length of path travelled by light in vacuum during a time interval of 1 by 299792452 of a second. That means 1 meter is equal to the amount of distance light travels in 1 by 299792452 of a second. This is a very small unit of time. So this is the distance that light travels in this amount of time. Second, kilogram. Kilogram is the unit of mass which is defined as a mass of the prototype which is present at the International Bureau of Weights and Measure. That means that there is a cylindrical bar which is placed at the International Institute of Weights and Measurement, and that bar is considered to be having a mass of 1 kilogram. Recently that definition has been changed, but it is not yet updated in the textbooks. The unit of time is second, which is defined as the duration of 9192631770 periods of radiation corresponding to the transition between two hyperfine levels of the ground state of cesium 133 atoms. Now I know this is quite daunting and quite confusing. This is quite weird definition. So in simple words, you can say that 1 second is equal to the time period required by the cesium atom for this many oscillations. In 1 second, cesium atom oscillates this many times. 9 Arab 19 crore 26 lakh 31,770 times the vibration is there in 1 second for cesium atom. So this is the unit of time, 1 second. Ampere is the current which travels in two straight parallel conductors of infinite length. So let's say we have two straight wires having infinite length, and the circular cross section of the wires is negligible. Then when they are placed 1 meter apart, and if they produce a force equal to 2 into 10 to the power minus 7 newtons. Okay, so when we have two current carrying wires which are of infinite length and almost negligible cross sectional area, and they are 1 meter apart, and if they have the force of 2 into 10 to the power minus 7 between each other, then we say that the current in the wires is equal to 1 ampere. So if the current is equal to 1 ampere and if the wires are 1 meter apart, then the force will be this much. Next, the unit of thermodynamic temperature or the temperature is Kelvin. Kelvin is defined as the 1 by 273.16 part of the thermodynamic temperature of triple point of water. The triple point of water is the point or the temperature at which the water can exist in all three states, solid, liquid or gas. So the Kelvin is defined as 1 by 273.16 part of that triple point of water, the temperature of that triple point of water. Again, you do not need to remember any of these things, they are quite abstract for now. Just keep in mind that there are some specific definitions. We will discuss one more thing, what is the important thing that you need to keep in mind while formulating the or while standardizing the unit. We will discuss that in a moment. Then the unit of substance amount of unit of amount of substance is moles, and it is quite simple. If we have 6.022 into 10 to the power 23 particles, then we call that as 1 mole. For example, 1 dozen is equal to 12. Now 12 can be anything, 12 particles, 12 apples, 12 bananas, anything. So similarly, if we have this many particles, then we call that the amount of substance is 1 mole. And the luminous intensity candela, luminous intensity is the intensity of the light. It is measured in candela, and candela is defined as the luminous intensity in a given direction of a source that emits a monochromatic radiation of frequency this hertz and has a radiant intensity in the direction of 1 by 683 watt per steradian. Again, this is quite abstract. Just keep in mind that first thing, the light is monochromatic. So let's say we have one monochromatic light, that is it is of only one frequency or wavelength, for example red light, let's say. And if that monochromatic light is of frequency 540 into 10 to the power 12 hertz, and it has a radiant intensity in the direction of 1 by 683 watt per steradian. Steradian is the angle unit of 3D angle. So just don't get confused. Simply luminous intensity is measured in candle, and one candle is equal to the amount of intensity which is emitted by a monochromatic light of wave frequency 514 to 10 to the power 12 hertz, and in a particular direction having power 1 by 683 watt per steradian. So I am again repeating, you do not need to keep all these things in mind. These are quite abstract definitions, but one thing you need to understand: the most important thing while defining a unit is that the unit must be reproducible anywhere. That means it should be the unit should be such that it can be reproduced anywhere in the world. For example, if I say 1 ampere, so 1 ampere can be measured anywhere in the world. If you have two wires, and if you can measure the force between the wires, you can easily measure 1 ampere current. Similarly, you can measure 1 meter also anywhere. Okay. Similarly, 1 second it can be reproduced anywhere in the world. If you have cesium atom and the instruments to measure the vibration, then it can be measured anywhere in the world. It does not depend on the location. Okay, let's say for example, if you take the unit of length as 1 arm length of ram. So let's say if you take 1 arm length of ram as a unit, then this unit cannot be reproduced anywhere in the world, because you will need ram everywhere. Okay, if ram is not there, then the unit will not be reproducible. So the units must be reproducible easily anywhere, and this is the main thing that we keep in mind while defining the units of any physical quantity. Now, before going to the derived units and dimensional analysis, let me just quickly tell you about one small topic, that is SI prefixes. So, whenever we take the measurement, then sometimes the measurement can be quite huge or quite small. For example, the mass of electron is approximately equal to 0.0000000. Let me count. I need around 29 30 zeros: 3 3 6 3 9 3 12 3 15 18 21 24 27, and approximately, okay, I might be off 1 or 2 zeros. So this is the mass of one electron. This much kilogram is the mass of one electron. Now, isn't it quite difficult to write this every time? So there is a way to write this thing in a simpler manner. We can write this like this: 9.1 into 10 to the power minus 31 kg. So these two are equivalent. Okay, you can write it like this or you can write it like this. Obviously you will prefer the second one. So this is called the SI prefixes. So when we have very small quantities or a very large quantity, then we take good use of this power of 10. So it is very essential to understand the name of the various prefixes which are commonly used as the power of 10. Now let's say the power of 10 is 18. Okay, just to tell you what I mean this. Okay, I will not write it again and again. Power of 10 can be 15, 12. I am only writing the most common ones: 3, 2, 1. So the power, when the power is 10 to the power 18, we say the prefix to be exa. The symbol is capital E. Then for 15, peta, symbol is capital P. Then tera. Then giga. You might have heard about these terms: terabyte, gigabyte, kilobyte. Mega. capital M, then kilo, small k, then hecto, small h, then deca, which is dA. Now the units can be negative as well. For example, -1, -2, -3, -6, -9, -12, -15 and -18. Again, just to tell you what I mean by this is like this. This is like this, okay, 10 to the power -15 and so on. So 10 to the power -1 is called deci, represented by small d. Then -2 is centi, again you must have heard about it, centimeter. Then milli, micro. This is a Greek alphabet which sounds like mu, okay, mu. Then -9 is nano, -12 pico, -15 femto, and -18 is atto, small a. So you need to keep the prefixes in your mind. So let's say I have an object which is having some length. So let's say the length is 1000 meter. So I can also write this as 1 kilometer because 10 to the power 3 of something can be represented as kilo. So 10 to the power 3 meter can be represented as 1 kilometer. If I say the length is 10 to the power -9 meter, I can also simply write 1 nanometer. Or I say 10 to the power -6 meter, then I can write 1 micrometer. If I say the value is 1 millimeter, that means 10 to the power -3 meter. So these are quite handy when writing the big or small, very big or very small quantities.